Hi, my name is Erin and this is my limiting reagent problem. It shows question number 61. If 175 grams of molten iron oxide reacts with 37.5 grams of aluminum, what is the mass of the iron produced? First, we need to determine what the question is asking for. Looks like it's asking for mass, which will be measured in grams, and of iron, which is Fe. Because this is also a limiting reagent problem, we need to determine which of the two givens is in fact a limiting reagent. So we're going to have to do this problem twice. Now we need to write and balance our equation. So iron 3 oxide, is Fe2O3. In liquid form, plus aluminum, also in liquid form, and it reacts to form iron in a liquid form and aluminum oxide, which is Al2O3. Right now this equation is not balanced, so we need to figure out how many of each. Here we show 2 iron, but only 1 here, so we'll need to make that coefficient 2. 3O, that's balanced. 1 aluminum and 2 aluminum, so in order to make that balanced, we'll need to add a coefficient of 2. Now we have a balanced equation. Then need to determine the molar mass of each part. The molar mass of iron is 55.85 grams. The molar mass of oxygen is 16.00 grams. Aluminum, 26.98 grams. And in order to determine what the molar mass of iron 3 oxide is, we'll have to add some of these together. So iron at 55.8, we'll have to do 2 of those. And oxygen at 16, we'll have to do 3 of those. And that equals 159.70 grams. So we can use that information and use the molar mass bridge to determine the amount of iron that's produced for each given. So for the given of 175 grams of iron oxide, we need to use the molar mass bridge of 1 mole of iron 3 oxide has a molar mass of 159.70 grams of Fe2O3. We then need to determine how many moles, and we also want to go to iron, so we're going to go to iron and Fe2O3. So we have 2 moles of iron and 1 mole of iron oxide, which you can see in the equation, 2 moles of iron and 1 mole of iron oxide. Then we're going to use the molar mass of iron, which is 55.85 grams Fe over 1 mole of Fe in order to determine grams of Fe. So we can see that this and this cancel each other out. This and this cancel each other out. And this cancel each other out, giving us grams of Fe as our final measurement. And once all these calculations are done, we multiply 175 grams by 1 over 159.70 by 2 over 1, which is just 2, by 55.85 over 1, you get an answer of 122.40 grams of iron is produced. We're going to do the same thing with our given of 37.5 grams of aluminum. So we're going to have 1 mole of aluminum over its molar mass, which is 26.98 grams of aluminum. And we're going to multiply that by the 2 moles of iron over the 2 moles of aluminum, because we want to then get to the molar mass of iron, which again is 55.85 grams over 1 mole Fe, which again, that cancels out that cancels out that cancels out that, and we're left with grams of iron. And when the multiplication is done on a calculator, we get an answer of 77.62 grams of Fe, of iron. So we can then go back to our original question, which was, with the given, what is the amount of iron produced, which for our first calculation gave us 122.40 grams of iron, and our second calculation gave us 77.62 grams of iron. And the way limiting reagent problems work is whichever given produces the least amount of your required answer is a limiting reagent. So since aluminum gave us a final product of 77.62 grams of iron, we can determine that aluminum is our limiting reagent, and the answer for this question, what is the mass of iron produced in this reaction, is 77.62 grams of iron.